Okay, good day. So you are attempting question 8 from 2018, June 2018. So it's saying in the diagram, O is the center of the circle, the radii, OH, which is OH and OG are drawn. A tangent is drawn from K, a tangent is drawn from K to touch the circle at H. HGJ is drawn such that GJ, where GJ is parallel to KH, O1 is equal to 2x. Now, so what we have there is that we see that before we attempt the questions here, we can see that we have parallel lines. And once we see parallel lines, we must think of what is it also corresponding angles, co-interior angles, alternate angles, which are the which you need to consider when you're looking at parallel lines. Okay, then what else do we see? That we see also that the radius, that once you see the radius, you must also know that radius are the same, and in this case that will make JON an isosceles, meaning to say this angle will be equal to this angle. It's something that you can actually quickly see before you attempt your question. Okay, so let's get to the question. It's saying name giving reasons 3 angles equal to x. Now, when we look at this angle here, we see that the arc, this arc is subtending JH is subtending an angle of 2x, and also it's also subtending G on the circumference. That's what we are having there. So the first angle here is going to be 8.11. The first angle is going to be G is equal to x. Y, we are saying angle as the center is twice angle as the circumference. Angles circumference. Okay. The other angle again, when we have G as x here, it means that we are going to look at the parallel lines. We see that we have an alternate angle here, H1. H1 is also equal to x. Y is equals to alternate angles. Alternate angles are equal. We are told that GJ is parallel to KH, so we can consider that. Then now, the last angle there will be, when we look at this angle, at this tangent, we see that they've got a chord here, and this chord is subtending the angle J. So it's going to be J. So J also is going to be equal to X. So the whole of J is equal to X. So it's going to be X. So it means that what we have there is turn chord theorem. Okay. Now, so moving on to the next question, 8.12. Prove that H2 is equal to H3. So we asked to prove that this H2 is equal to H3. Okay. Now, want to first see something here. When you look at K, H, O is equal to 90. It's equal to 90. Why are we saying that? Because of diameter, your radius is perpendicular to your tangent. Perpendicular to your tangent. Okay, that's what we know. So it means that to find H2 is therefore 90 minus x. It's going to be equal to 90 minus x, H2. That's what we can see, that H2, to find H2 here, we say 90 because the whole of the angle H1 and H2 is equal to 90. So it means that to find KH2, you have to say 90 minus x. Then what else do we do there? We have to check this triangle HOJ. Now HOJ is an isosceles. So it means that J1 is equal to J1 is equal to H3. That's what we have there. Now, because of that, how do we now get H3? H3, we know that we're going to say H3, since the whole of triangle, if we add O plus J1 plus H3, we get 180, because sum of interior angles of a triangle, we get 180. So we're going to say H3 is going to be equal to 180 minus 2x divided by 2. We are going to divide it by 2. Why are we dividing by 2? Because H1 and H2, H3 and J1, they are equal. Okay, that's what we are saying here. So we're going to divide by 2. And if we divide by 2, 2 into 180, we get 90. 2 into 2x, we get minus 2x, minus x, sorry. It's going to be minus x here. (90 minus x), okay? And therefore, H2 is equal to what? Therefore, H2 is equal to H3, because they are both 90 minus x. So we are done with that. Now, let's move on to the next question. Is the second part, 8.2. 8.2 is saying, in the diagram, KLMN is a cyclic quadrilateral with KLM 87. Diagonals LN and MK are drawn. P is a point on the circle. P is a point on the circle. And MP is projected to T. MP is projected to T, okay? And then what we have got a point outside the circle called LP is drawn. LMK is equals to Y. NY is equals to 2y. Now, name given reasons another angle equal to y. Another angle equal to y. Remember what I said when you're doing circle geometry, we have to turn your question paper. If you turn it like this, you find that M, which is y, is and N2, they are in the same segment. They're in the same segment, so they are equal. So 8.21 N2 is equals to y. Y angles in the same segment. Okay. Now, what else do we have there? We have got 8.22a. Calculate giving reasons the size of y. Now, how do we get now the size of y? So we know that opposite angles of a cyclic quad, they add up to 180. Opposite angles of a cyclic quad add up to 180. So we're going to have N2, we have got y already. So we're going to say 2y plus 87 must give us 180. Y opposite angles of cyclic quad. That's what we are saying here. So we're going to solve from there. It's going to be 3y is equal to 180 minus 87. Then it's going to give us what? 180 minus 87. We get 93. 3y is equals to 93. Then what is going to be 93 divided by 3? We get 31. So y is going to be equals to 31. So our y is equal to 31. So we already find the value of y. Then we move on to 8.22b. It's calculating the size of TPL. TPL is TPL. Now, TPL is equal to 2y. Now, look here. We have got two cyclic quads here. Look at the cyclic quad of cyclic quad. Cyclic quad here. The cyclic quad that we are having here is L. That we have to look at LP, M, N. So it's a cyclic quad there, as you can see. And the opposite angle, that is what called opposite interior angle, is what is actually what you call it's N2, which is 2y. So our TPL is going to be 2y. So here is equals to 2y. Why is it 2y? Exterior angle of cyclic quad. That's what we're going to. So exterior angle of cyclic part is equal to opposite interior angle. That's what we have here. So we are done with this. So that was the that was all. What you need to remember here, you need to check closely your what is it to revise your theorems and understand them very well and try to link them up as well. Okay. Then also when it comes to these questions, like also parallines, when you see parallines, a hint there, you must look for those triangles. You check if there is anything that you can deal with alternate angles, corresponding angles, and also co-interior angles. That's what you have to look for. And when you see the radius line from the radius, you must know that all the radius are the same, of the same size. Okay. Thank you.